I built a Lego HexTrak tile, put it in my nscale layout, and ran a train through it. Which is obviously the correct thing to do, because model trains are fun, Lego is fun, and I have a 3D printer. So naturally, wanted to be able to play with Lego on my 3D printed railroad layout. This is not about replacing traditional scenery. I love gluing scenery down. I saw the Bricks and Trains YouTube channel, and his mostly Lego layout looked fantastic. It made me want to bring a childhood favorite into my HexTrak layout. And yes, I know Lego minifig scale is not even close to nscale, or Lego L scale is not close to nscale. But who am I to tell the minifigs they cannot railfan? So today I'm using OpenSCAD and 3D printing to make a HexTrak tile with Lego compatible studs. Glue it together, put it in the layout, build something on it, and run the train past it. The setup. Quick recap. If this is your first HexTrak video, I'm building an N-scale model railroad using HexTrak, which is a modular system based on hexagon-shaped tiles. I like HexTrak because I do not have a whole room for a permanent layout. I can build one small module at a time, store it, rearrange it, and keep changing the railroad without needing a basement empire. My earlier 3D printed HexTrak tiles were pretty normal. Hexagon base, feet underneath, Kato unitrack alignment. Print the pieces, glue them together, run the train, feel good about myself. But this time I wanted a tile where Lego could become part of the layout itself. Not just a Lego set sitting next to the railroad, actual studs, Lego studs on the HexTrak tile. So I could snap on a building, make a little railfan spot, build a tiny work zone, or just put something silly next to the track because this is my layout and I can. That is the beauty of modular design. Traditional scenery can live on one tile, Lego can live on another. The whole point is that each module can have its own personality. The OpenSCAD part. To make that happen, I started with my existing HexTrak design in OpenSCAD. OpenSCAD is not the flashiest CAD program, but it's great for this kind of project because everything is controlled by the numbers. The tile size, plate thickness, stud diameter, stud height, stud spacing, track clearance. If I need to change something, I can adjust the parameters and regenerate the part. For this Lego tile, the idea was simple. Keep the HexTrak shape, keep the railroad alignment, add a grid of Lego compatible studs on top. Leave room for the track, then print it and see if the bricks actually stick. On screen it looked great, and that is always the dangerous part, because CAD will happily show you a perfect idea and then the 3D printer gets to vote. The first version. My printer cannot print a full HexTrak tile in one piece. For earlier HexTrak tiles, I would split the module in half. One half, other half, glue them together, done. So I tried that here too, and honestly the first version proved the idea. Tile printed, the studs printed, Legos kind of could stick. This was a big win, but when I looked closer, some of the studs were not as round as I wanted. They were slightly oval or egg-shaped. Tiny plastic breakfast potatoes. When the whole point is connecting to Lego-style parts, the studs mattered. If a hill is lumpy, that is scenery. If a rock is weird, that's nature. If a Lego stud is weird, that is the part of the project that has one job. So the two-piece version was not a disaster. It was not a failure. It was the prototype that told me, this works, but you can do better. The four-piece redesign. I changed the plan. Instead of forcing the Lego tile into the same two-piece strategy as my earlier HexTrak modules, I made it into a four-piece printed assembly. Four smaller pieces gave the print more breathing room. It also allowed me to lay them flat on the print plate. It made the parts easier to fit in the bed. It gave me better control over how the studs sections printed. And if one piece came out wrong, I would not have to reprint half the tile. That is one reason why I like to use OpenSCAD for this project. The idea can change without starting completely over. I can go back to the file, change the design, regenerate the pieces, and try again. This is still a fun Lego train experiment, but the way to get there is very much a maker project. Design it, print it, look at that weird part, change the file, print it again. The print and assembly. Once the four-piece version was ready, I sliced the parts, printed them one at a time. Do the studs look better? Do Lego pieces actually stick? Can I remove them without destroying the tile? Can this thing actually become part of the railroad? The answer was yes. The studs were usable, the Lego bricks stuck, and now I had four pieces that needed to become one HexTrak tile. So I dry fitted everything first, and then I hot glued the pieces together. Hot glue is not the fanciest assembly method in the world, but for this prototype, it made sense. It was fast, and it filled the gaps. And honestly, super glue just doesn't work fast enough. One note, hot glue does leave a little stringiness, but that's okay. Got the tile from printed parts on the bench to actual layout module without turning the assembly into its own side quest. Once it was together, it was time for the real test, not just a brick test. The railroad test. The layout test. I put the Lego HexTrak tile into the layout. I connected the track. I snapped the Lego pieces into the studs, and then I ran a train through it. That is the moment where this stopped being just a CAD experiment and it became part of the railroad. The train moved through the layout, the Legos stayed attached, the minifigs were rail fanning. This is exactly what I wanted from this project. Not perfect scale, not museum realism, just a fun little crossover between model trains, Legos, OpenSCAD, and 3D printing. Now building on it. Of course, pressing one test brick into the tile is not enough. If I'm making a Lego compatible HexTrak, I want to actually build something on it. So the next step is making a small little Lego scene. Maybe a little rail fan area, maybe a work zone, maybe a town corner, maybe something completely ridiculous. That only makes sense because it's fun. The cool thing about this, I can do whatever. And that's the whole point. This is my HexTrak layout. It does not all have to follow one style. One tile can be experimental. One can have the campground on it. One tile can have Lego minifigs waiting for a train that is absolutely not built to their scale. Modular design gives me permission to make each tile its own little world. The more I work on HexTrak, the more I like the idea that the layout can grow into a small creative experiment or small creative experiments. I do not have to build the perfect railroad all at once. I can make one tile, try one idea, learn one thing, then move on to the next module. This Lego tile fits that perfectly. It's playful, it's useful, it's a little weird. It gives me a reason to improve the OpenSCAD design, test 3D printed stud tolerances, and still end with the train running through the scene. That is the kind of project I enjoy. Conclusion. So now I have a Lego compatible HexTrak tile in the layout. The 2-piece prototype proved that the idea could work, but slightly over oval studs told me the print strategy needed to change. The 4-piece version worked better. I hot glued it together and glued on the feet. Lego bricks stuck to it. I installed it in the layout, and I ran a train through it. So now I have a HexTrak tile where I can build with Lego, run an nscale train through the layout, and let the minifigs do what they came here to do. Real fan. This is not the final version of the idea. I still want to test different print settings, build more Lego scenes, and see what kind of brick-built scenery actually looks like. Now I'm happy. Model trains are fun, Lego's fun, and an OpenSCAD plus a 3D printer gave me a way to put them on the layout. If you like the idea of HexTrak or you like this video, check out my channel. I have some more like it. And until the next time, I'll see you then.